Hi, everyone. Welcome today. Thanks for joining us. We're just going to wait a minute or two here as we get settled and get everybody into their virtual seats before we get started. Just want to make sure we give everybody a chance to log into the platform. Just a couple of logistical items that we can go through to start. I'm Patrick Dunphy. Good to see everybody out there. I may go off video at some point just to make sure we can focus on the content. But I'll try and stay up here as long as I can as we go through today. I'm the VP of Marketing here at Anark. I'm also joined by Jim Martin, who's our Director of Customer Engagement. And now for the logistics of the platform. If you haven't used Livestorm before, there are two capabilities that we'll use as much as we can today. One is if you have questions, please click on the questions button. I know it's really difficult to figure that one out, but use the questions for questions and we can answer them directly in reply to your question as we go. And we'll try to do that as best we can today as we go through the session. Additionally, we have the chat window. We'll use the chat window a couple times during the session today where we will be asking all of you a question. You can share your feedback through the chat window and we'll bring that up, talk about it, directly discuss with what you're chatting to us. But given the size of the group that we're expecting today, we wanted to make sure that we use the chat window for that rather than managing the on-mute, off-mute type of scenario. So we'll get started again here in about 1 minute, but thanks again for joining. Looking forward to a great session. Just because it's always confusing as I see more people logging in. It's always confusing if you log into a meeting and people are sitting there silent. My name is Patrick Dunphy. Welcome. And we'll be getting started here in just a minute. All right. This session, just the last logistical note, people always ask this question. The session will be recorded. A PDF of the presentation material will also be available after the event when you go back to the platform. If you return to the platform to rewatch the replay, you'll also see access to the PDF to download. And so you'll be able to access that after the event. Great. So excellent. Thanks everybody again for joining us today. Again, one last time, I'm Patrick Dunphy. I'm the VP of Marketing here at Anark. I'm joined by Jim Martin, Director of Customer Engagement. We'll hear from him in a few minutes as he shows some real examples of what we're talking about in theory through this guide for digital engineering based on the DoD Instruction 5097 blueprint. For those that aren't aware, what has happened recently is the DoD released this 5097 instruction, and with that, they've put together a blueprint for success that will really transform product manufacturing. And I don't think this is just something that will transform DoD contracting companies only. This is more broad because this is really a definition and a way of thinking about digital engineering that can drive broader impact than just within the DoD. But if you are working with the DoD, as of December 2023, any new programs will have to abide by the ideals put forth in this instruction. The document here on the left, and then the visual from the document on the right that really captures a whole host of elements, digital elements that have the opportunity to transform manufacturing. Things that we've all heard about before: digital twin, digital thread, digital artifacts, digital models, digital engineering ecosystem, a lot of digital things. But how does this all come together? So while the instruction 5097 on digital engineering offers an excellent blueprint, what we wanted to do was put together, based on working with a number of customers in the industry, put together a guide, a manual, if you will, on how to use this information in the blueprint to your advantage. And that's what we're here today to do. This is what the webinar is all about, is to provide that guide to you, share that information with you, share that insight, and talk through the blueprint but map it into practical applications based on industry experiences. So let's start with the digital engineering environment that's defined in 5097. If you look at what it says and what it talks about, you have the collaborative environment for digital engineering. You have collaboration between different groups, contractor to government, government to government, contractor to supplier, and others. You have customers, regulators, suppliers, and more that need to be connected and integrated into the digital thread. And then you have a specification for feedback. There needs to be feedback in a functional, valuable digital thread and digital engineering strategy. And that's really one of the areas that we'll be focusing quite a bit on, is making sure you can close that loop and not just connect people to the information they need, connect the digital twin to a strategy, but also get the feedback, get the information back so you can better influence and update and continuously improve the product through your single source of truth. So how does this all come together? Well, this is what it looks like if you took a practical approach to it. You saw the circle on the slides relating all these components in various circles around that graphic that comes from 5097. But this is a version of it that takes a sequential approach to break down all of the source information from digital models and artifacts into a way to source those to define an early digital twin definition that can then be turned into a digital twin realized. But then you also have the ability, as you look through the instruction, to deliver digital thread process value. But you can't do that just one-to-one. You can't say, hey, here's a digital representation of the product, and now I have a better supplier collaboration process. You need to think about ways to compose experiences that all the people in the ecosystem, this digital engineering ecosystem, can best take advantage of. And a large part of that is they have to be able to share their knowledge and their information back with everyone. And then we can get to the digital thread processes. So let's start with digital twin. I will break it down on the left-hand side and start with one of my favorite quotes from Albert Einstein, which actually isn't the direct Albert Einstein quote. If you want to know, connect with me and I'll give you the full quote, but it's much nerdier, as you would expect. Very interesting, but it really comes down to keep things simple. Make it as simple as possible, but don't make it more simple than that, because if you do, you won't get actual value or results out of what you're trying to do. And that's the same thought and can be told true for digital twin. You need to find the simplest first value for digital twin in order for it to count, for it to make it valuable for you. And it really starts with static digital twins. If you think about the digital twin definitions that are out there, you have components, products, systems, and processes that all stack up in this slide. But then you also have a continuum of static, which is not connected, not censored up, not phoning home and sending signals back, but really the early stage digital product definition, the virtual representations, the models, the simulations, and ways to predict real world behavior that if you need to, you can censor it up in the right way to get the dynamic digital twin, which is real world, validated, real time, and you get a lot more value out of it. However, it does cost more. It is more complex. And so businesses, companies, manufacturers need to decide where on the continuum they need to land. Or do you need a low cost component twin, or are you looking for a large scale, high cost, high complexity system twin that provides a huge amount of value, but also costs a lot, takes amount of resources up front, and where do you fall? And so let's walk through how you can test out some theories and think about this as you break down the framework. How do you find the simplest first digital twin value? Well, it starts by identifying and sourcing that information. So if you think about the component or product or system or process twin that you're trying to define, there's a whole host of virtual representations, digital representations, models, simulations, related files, data that exist in one or more authoritative sources of truth. So if you start by identifying the digital models and artifacts to make up the digital twin definition, you're on a good path. You then have to source those to a central location so that teams, cross-functional teams, can discuss and think about, is this the right fit? Will this deliver the value that we need? Do we need it to be more complex, less complex? Where do we need to add sensors? And let's talk about all of the things that we're looking to gain by defining this digital twin representation, and then later the dynamic digital twin version. So to keep it moving and mix it up a little bit, I wanted to hand it over to Jim. So Jim, you can jump in here. Wanted you to maybe take us through an example of how we can identify and source content and digital twin static definitions.
Yeah, thanks, Patrick. Hello, everybody. I know quite a few of the names I'm seeing here. So yeah, this is an example. If you've seen this before, this is Anark Collaborate that we're looking at, and we have some additional what we call content items that you can start to think of as these static digital twin items. And you've seen some of the ones below here that have different examples of detailed MBD models from NIST and others that are important. But what we've created today is a couple of new ones that involve this drone example. And we created a review version of it and a what we're calling a complete or final version of it. And we also have a work instruction version of it. And so really what we've done is assemble the information that was important. And when I pick this link, this is essentially pulling together the information from the authoritative systems that were needed to start the review process for this drone. So again, as it may or may not be needed or even available, but if there is a 3D CAD model that could be shown, you could have the different views that are important to show people. We're going to focus a lot today on this base plate. It's a new design where we're modularizing the base plate from the different arms so that it can be a 4 or a 6 arm design. We're looking at the mounting location and the stress variance in that base plate. You can also see that we automatically, let me go back here. We automatically generated the bill of materials that are associated with this. So this is very typical of how we get information from authoritative systems and pull it together into what could be thought of as a static digital twin, but it can be more than that. It's more than just the CAD model. So you'll see a lot of systems that just throw a 3D CAD model and assume that that's the entire technical data. And it can also be a static bill of materials or a dynamic one. You could have, for example, this is the FAA drone requirements document. I think this one is a little bit dated, but this is the version I was able to get. You have other types of working documents. So at this early review stage, you may be looking only at the requirements and how to fit requirements to functional to physical type of things that you're looking at within a legacy design versus a new design that you're considering. And we can even attach things like a SysML file. In this case, there's not a visual necessarily. So there's other things. We can really attach any type of file to create a static digital thread item that feeds into the activities that need to be reviewed and pulled together from these authoritative systems. It makes it a lot easier for people to get all the information they need in one place and collaborate on it. And then, for example, if you did need to download the XML file, SysMX file, because you want to read it in somewhere and look at those requirements in Magic Draw or some other system, you could do something like that also. So just kind of a starting point for showing how that information gets pulled together and how it makes it much simpler for anybody who has authoritative rights to access this, whether it is inside of the organization, somebody in the government, or the different suppliers or partners that you're working with through a web-based approach and a link that allows them to very easily get to the information they need. It accelerates the ability to get this information out to people. So I'll pause there and hand it back to Patrick, and we'll go through some of this in more detail as we move forward.
Excellent and perfect. Thanks, Jim. Yeah, and I think one thing to note there is that as you went through that, one of the challenges that companies face with defining this early stage static digital twin is not all the content necessarily comes from an authoritative source of truth. Some of it does, but maybe not all of it does, especially early stages. And as you start to evolve and decide on what the right strategy is and where you need to deliver the most value for the organization and for your customers, that's a key thing to consider. Is getting that information in early and sourcing that into a central location is a key way to connect everybody together, get everybody on the same page, and start to maybe uncover things that are going in a direction that you don't want them to go in. And that can include data being managed in a place that it shouldn't be managed, and give you an opportunity to bring that into the authoritative source of truth. So lots of opportunity here to improve processes. We'll get to that more as we talk about digital thread later in the session today. But just a great example there, Jim. So thank you for that. Now I'm going to switch gears a little bit and ask all of you for some feedback, because maybe we're correct here. Maybe we've captured everything, but I'm guessing we didn't. I'm guessing with the types of folks that we have on the call today, that if you hop into the chat window, you have some suggestions above and beyond what was just shown that would make for a good digital twin or digital product definition. So have at it. We have a couple, I'll call them preloaded thoughts that we think are a good fit, but we'd love to hear from you. So click the chat button, type in your thoughts. I'll give it a minute here. But Jim, could you just rattle off the things that you did have in there? And then I'll try and think of some additional things that aren't in there while some folks are typing or adding in their additions.
Yeah, so once again, we called this a review or an initial digital twin. It could be any terminology that you want, depending on how you're working. In this case, we did have the 3D CAD model. We had a requirements document from the FAA. We had another more, perhaps a systems engineer within an organization created a more detailed requirements document that pulled together information that led into the initial designs, and we're able to generate a SysML file that could be used by somebody to start trying to understand the requirements up front, and then be able to relate that to how that design is going to proceed, either through the conversations with the OEM, the supplier, and the government altogether, to make sure that everybody up front is looking at the same information and understanding the requirements before they go deeper into design, prototyping, and other activities.
Great. So it looks like we have a particularly shy audience. That's my, once again, prompt to click the chat button and type in anything that you're thinking. But as luck would have it, we do talk to lots of folks about this. And so one thing that comes to mind, I'm not sure if you showed it, Jim, was there anything in there as it relates to quality and kind of critical characteristics to quality within the product itself? That's one that comes to mind.
Yeah, so in the we had multiple static digital twins. The review one didn't necessarily have that. That could be one of the requirements, of course. But in a different one that we'll show you in a second, there is some additional quality documents that are in there that need to be adhered to, and we can talk about that.
Okay, good. And then additionally, again, I'll put words in the shy audience's mouth in terms of other things that we've heard from folks like all of you over the years. Is another one would be from a long-term standpoint. Are we thinking about this product for being fielded and out in the field for a year or two, or is it out there for years and decades and many decades? A lot of our customers and a lot of companies we work with have products that last quite a long time out in the field. And from a sustainment standpoint, you need to have considerations around how do you maintain a digital record of that product for the long haul, right? Long-term archival, retrieval, et cetera. So that would be another area that I think we could jump into here in a moment. Jim, anything else come to mind? I know it's a loaded question for you. You're about to show us something else in a few minutes here, but anything else come to mind that we would also want to add to this initial static digital twin definition? That's a no.
That's not. I guess we don't have
All right.
All right.
Great. Yeah. So if you have any as we go, I'm going to go through the next few steps here. in terms of finding the simplest first digital twin value. But if you have any ideas, drop it in the chat and we'll make sure that we incorporate it into the next example that Jim walks through. Great. Okay, so there are other things that we need to consider once we've reviewed this initial definition, right? So we can identify all the components, all the elements that make up a digital twin definition. We could source all of those into a central location, start talking about them and review them and provide feedback to all the right people, provide access and visibility to all the right stakeholders, up to and including customer visibility. Early customer visibility is a key element of doing this the right way, or at the very least, driving down time to market and doing this faster with early customer input. But then there's the opportunity here to automate the static digital twin sourcing so that you have a live running connection to ensure that anytime you go back and look at this data throughout the product development process, you have access to the most accurate version that's accessible to everyone and actionable so you can do work, collaborate, and get other things done along the way. So that's a key element here. But then additionally, after that, it's now time to use this information, put this data to use, leverage the digital twin models and artifacts in digital thread processes. So if I jump back for a moment here, just looking at this continuum, there's an opportunity to really think about what you're trying to achieve with the digital twin in the early stages, and then benefit from that as you proceed through the development process by connecting people and all of this digital product definition together in a digital thread, or really a set of processes that make up the digital thread. All right, so back to where we were. At that point, once you've started to think about ways you'd like to leverage this data downstream and leverage this definition downstream, you can validate the models and the artifacts. You need to validate that the models and the artifacts will represent the real world behavior and performance of the product. If you don't, well, why are you doing it? You may end up with a complex, high cost solution that you put out to the market when really you could have been somewhere maybe more in the middle of the continuum of the curve. Or maybe you could have gone very simply. The example that somebody I was talking to the other day gave me the idea for is a water heater. Customer outcomes on a water heater in the basement of your house. The customer could say, yeah, that'd be great and real nice if you gave me a connected app that told me the temperature of the water, how much water was in the tank, how many minutes I have left of hot water. But is that really the number one problem that they have? What you might find out is all you really need is a simple sensor that could detect a leak so their basement doesn't flood. And any customer that could have fully basement proof or fully leak proof water heaters in their basement would likely buy more of those if they knew that it was guaranteed and it would never cause damage to their basement. Not an expensive sensor, not an expensive solution, maybe not as glamorous as the other end of the spectrum, but likely to actually drive improved product adoption, sales, and customer retention. So just one example of where maybe the simpler answer is true. So let's go back to an example. We'll go back to the review process because we haven't actually shown the review aspect of what we could do with the data that we're looking at. So I'll hand it back over to you, Jim, for a couple minutes here.
Yeah, so before we actually go into the review process, let's take a look at the static digital twin content that we've created. So we looked at the review version. So it's clear that at the very beginning, you're going to have one variation of the digital twin package that you're going to create. And then as time goes forward, you're going to progress and have different variations of those. And I have one here that's called the complete package. So when I open this one up, this is what we may call a complete package that you'll see has some additional information in it. So the initial early stage packages could be generated from a desktop where we pull together the different models and documents and publish them out. A lot of times what you'll find is if you're tied into Windchill or Team Center or other authoritative systems, a lot of this information may be within the packages that are established within those systems so that you can have the model. You can have some of the initial bill of materials. You can have things like legacy information. In the aerospace and defense industry, we have customers that have literally millions of legacy content items. And many of those are nowhere near model-based definition or 3D CAD, but they're still important to maintain knowledge and history based on decisions that were made. And then you can start to have things like, for example, if you have some stress results, this is a static image from a CE analysis I did on the base plate. And then there's some other information. We talked about being able to have long-term archiving. So in this case, there was a STEP AP242 edition 2 file of the base plate that was generated in case that's needed at some point in the future. And we also attached a QIF file. So we talked about generation of using authoritative systems to generate this. This package, this technical content item could have well been automated from Windchill or Teamcenter versus some of the earlier versions that could be hand created and published. But at the end of the day, it's all technical content that somebody has ease of access to. And then when we go back to a point of this is my activity feed that involves the conversations that I have related to the technical content, this is where I solve problems internally with partners, with the government, with others. So here you can see we had a conversation related to the early review documents. And so we talked about the base plate being critical because that's going to be a new design. We highlighted in the document from the FAA what's important because this is going to be a category 2 drone versus the different categories that are out there. But then you can see there's another conversation here. This is going to be a review of the final design. And so what I may do here is start a collaborative conversation. And again, I don't need access to the authoritative systems. I've already pulled the information into the static digital content item, and I can use any of the visuals from either the model, the bill of materials. In this case, let's use a legacy drawing to do a collaborative activity that involves some markup and commenting on something that we need to be careful about. And so what I'll do in this case, I'm going to mark off, this was a one-piece design that was a legacy way of designing. And we're going to mark off from somebody with experience to show that these were the areas that were failing before when it was put through heavy lift scenarios. And so I can mark it, and I can add a note, and I can fix my spelling, failed locations. And you can have rich text and different sizing and images, but I'll keep it pretty simple here. And so anybody who's part of this conversation, internal or external to my organization, this will be part of their collaborative conversation. This is fully archivable. This can be fully tied back into your authoritative systems and stored there as a record of what was discussed, because what was important is that this was a failure point for this previous design that was using a legacy drawing. And then what we can also do is confirm, and let's go back to some of our content. And again, any of the visual content I can mark up. So what I may do is pull up this stress analysis. And what I can do is show that, yeah, in this case, there are no stress points. So let me go through and mark up that one corner. It's a little different design. So it's not one-to-one, but the main areas are here, these little corners. There is a little bit of a stress there, but it's not exceeding anything that's going to be any kind of failure situation. So this will handle the stresses we expect. Okay. And so this could be marked up on CAD information, documents, drawings, anything that's important as part of this conversation. But again, this gets you into the review of the technical data that's important. It has it all in one place. It's fully traceable as to who commented, what was commented on, and what the replies were. And it's based on different content items. One of the conversations was based on the review. There was some back and forth that concluded something. And then we updated to a new content item. And then we confirmed that the information was accurate and what we needed for the final design as part of this digital engineering process that we're talking about. So That's all I wanted to show you. You can combine any type of information together with the people that need to be part of it to solve problems well before you get into production or manufacturing.
That's great, Jim. Thanks. And Peter just asked a question, or just commented in the chat and asked about the model being marked up. I think that's what you were just showing, but Peter, if not, let us know. Anything that can be visualized here in this platform, like within this digital product definition, can be marked up. If it's a file that's external, a lot of people will capture a screenshot and email that. That screenshot that's marked up can also be uploaded to the discussion feed. So one way or another, yes. Obviously, not every last bit of everything can be visualized, but in these models, 3D model here, as Jim's pointing out, can absolutely be marked up. And everything else that he just marked up as well.
Yeah, Peter, absolutely. Yeah, I know Peter and the folks from BAE, and yeah, you can definitely mark up this content. And I'll just say, to move it along here, markup of 3D CAD. 3D CAD. And I'll just leave it at that for now. The other thing to point out, you can mark it up. You can isolate GD&T. We don't have GD&T in this model, but if you have a model that has the GD&T or the full annotations, you can mark it up. You can add notes that include GD&T. Say somebody's created an annotation that's incorrect, you can mark it and write in the screen area the actual GD&T the way it should be. Any of the GD&T or electrical libraries or other type of libraries, we can load them up and you can use the terminology that you need within the markup itself. So it kind of overlaps a little bit with what some of our customers are doing with 3D PDF. They're doing markups in 3D PDFs, where this will probably give you a little more flexibility to be able to do that.
Yep, great, good stuff. And one of the reasons why we wanted to drive some of the thoughts and feedback in that review state to the discussion chat in the platform is because we really wanted to just very straightforward demonstrate that conversations that happen in these chat windows, in Teams, in different places, in email, can all be brought together side by side with this static digital twin definition and give more value downstream as you get going in a development project. So a lot of goodness here. Thanks for walking us through that, Jim. But let me get us back to the next phase, which is going into the dynamic mode. Now, from a dynamic mode, we've set the stage with the static digital twin. If you need to censor things up, which a lot of people do, there's then the dynamic mode, where you now have had ample discussion, ample opportunity to bring all the right stakeholders together, really figure out, do you need a fully censored up mobile app experience for a water heater in the basement? Or do you just simply need to prevent catastrophic failure for your customers by adding the right sensor at the right location? Go have all those discussions, define the failure modes, define the things, talk to people in a place that's fully traced and fully trackable. So back to, again, this concept of the feedback loop down at the bottom, close the feedback loop, trace the discussions, and tie that all together with the authoritative source data as well. Once you do that, censor it up, monitor and feedback from real world and real time performance. And then as well, as described in the 5097 instruction, continuously improve digital twin definition and related digital thread processes. So it's not just about keeping the product functioning well and long lifespan. There are also processes that can be made better by understanding performance, understanding operational procedures and how they're working in the factory floor or within your supply chain. And there's lots of opportunity for gains as you start to connect all of this collaborative discussion together. So back to this again, that's what we covered there was really the first half, where there's a lot, right? There's a lot to identify, source, review, automate, leverage, and validate, and then continue on into the dynamic digital twin environment to connect, provide feedback, and improve. But going beyond that is the digital thread. Again, the 5097 instruction offers a great blueprint. A lot of, all of the words that are arranged in this guide that we're going through today are in the instruction of 5097 for digital engineering. But this continuum, this concept is really to help guide the fact that once you have all of this defined in gray on the left, you can now compose differentiated experiences for your internal and external teams, bring customers into your processes, bring suppliers and drive supplier visibility earlier on in your development cycles, and really tie in subject matter expertise and knowledge to enhance the content that's being exchanged, discussed, and otherwise untracked outside in email and other systems. So again, the digital thread processes on the right here are many, and some are probably not even shown. I'm sure if you look at this on the right, beyond requirements analysis and product definition and work instructions and others, you may have some other thoughts. So hold that for a moment and think about what else you might have here. But I wanted to highlight one thing. The digital thread has long promised a closed loop digital utopia. And so why is instruction 5097 specifying things around digital thread processes? And why are there still opportunities for gain left across many, many manufacturers in terms of how they could work better and smarter together? Well, really, it's because the promise of the digital thread really looks more like this, where systems and machines are much more connected than they used to be. But the people in their daily work and the processes that they follow to get the job done, to deliver great products to market and to their customers, it's still largely disconnected and flies around in untraced, untracked systems where there's no closed feedback loop. So we're really, from a digital thread standpoint, looking at how tying collaboration, just as instruction 5097 for digital engineering articulates, tying collaboration together and bringing all of that information back to close the loop on feedback and traceability, so that all the individuals around the ring here are connected together and they can talk to each other, or they can talk about the data that they're sharing with each other, or they can just simply exchange the data and wait for the questions to be posted, shared, and reacted to. So that's a big piece of the puzzle, is trying to solve that problem, so that when you get to the opportunity for realizing value from the digital thread, you are actually able to power better processes because you're connecting your people and the collaboration data to the digital thread, which is those pre-existing connected systems, so you can maximize the value. From the instruction, as it describes on the left-hand side here, there's a lot of things that are detailed out, all of which are important to consider, which include interconnections and traceability, controlled interplay of technical data, software information, and knowledge, really kind of thought about in the green box on the right-hand side around connecting knowledge and making sure that that's tied together side by side with the technical data that's being traced and tracked and shared, connecting authoritative data and orchestrating information across the system's lifecycle. Sounds obvious, but an important thing that's often challenging for a lot of businesses. Empowering decision makers to access, integrate, and transform data into actionable information. I've talked a lot about the closed loop feedback aspect and the importance of that, as well as extracting data from, and adjusting the usage of models to carry out different activities. So those different activities are on the right-hand side, but these aren't all the activities. So again, what I would ask is if anybody would like to make suggestions, type it into the chat. You can do it now. You can do it later, whenever you'd like, or you can just think it to yourself and maybe we capture some of the ones that you're thinking about that weren't on the right-hand side here. So I'll just give this a moment as we set things up. And then, Jim, I'm going to show one quick video and then I'll hand it back over to you again. So feel free to type away, but one that we have that we think about a lot, and we have a lot of customers that talk to us about this one, is improving supplier collaboration. The flip side of this could also be customer collaboration, right? Bring customers in early, bring suppliers in early, good things happen. Oftentimes that looks like problems are found earlier so that you're not worrying about late stage changes. If we were to just show this example, kind of playing off of what Jim was showing before, you can bring together your suppliers with your sourcing teams, with procurement, with your engineering folks, and make sure that everybody's on the same page because they're looking at the same content. They don't necessarily need to be using the same CAD tool. They don't necessarily need to be using the same authoring application, but they can come into one place and bring together their discussions that are often disconnected into a central hub that drives it all together. Jim mentioned earlier GD&T, product manufacturing information, PMI. It's also important to think about things from a manufacturability standpoint and provide access to all of that critical to quality, control characteristics that you would have in terms of dimensions. But on the flip side, what we hear from suppliers a lot is from a deviation request standpoint, it would be great to have better traceability on what deviations were requested, what deviations were accepted, who accepted it, and what the detailed conversation was that transpired to get to that acceptance level for a deviation. And so this happens a lot with suppliers and OEMs, but when it happens in email, it takes weeks. In one case, we heard months to retrace the steps and understand who said what so that they can prove out that it's okay to be submitting the part that they have. So again, connecting everybody together is a critical capability, closing that feedback loop, and that's good for supplier collaboration. It's good for customer collaboration. It's good for really any type of collaboration and review. So Jim, I think we have time for one more example. And then as promised, in terms of the timing of today's event, we'll start to wrap it up after this.
Yeah, one of the things I wanted to show was this final content item. So we talked about getting information from the authoritative source of truth and using these to connect to SME knowledge. So for example, one of the items Pat talked about was work instructions. And we see this all the time where people are trying to modernize or update how they're communicating some kind of process. And so in this case, it's a very simple example where we're entirely using just the CAD model to go through different steps to show how, for example, you have to swap out the circuit board. And again, very simplified, but showing visually with other type of very simple information right now on the left. But we could put a lot more detail in there. We could put a lot more detail in the graphical region. We could have other attached documents related to any one of these particular steps. But the goal is to leverage the information that we already have to further the SME knowledge, because what we're seeing in the aerospace and defense industry is that subject matter expertise is going away. They're retiring, they're moving on. So we want to be able to capture this in modern forms together with legacy information to basically put together another digital thread process that can be stored and used well into the future. So this is a typical scenario that we'll see in aerospace and defense that can be very directly related to the DoD initiative. But it's not just DoD, it's anybody who really needs to more carefully show something to somebody in these work instructions and then ask questions, is this the right way to do it? Did I get this right, or is there some other way that we should be approaching this that I'm not aware of? So again, it's information that's being reused in a lot of different ways.
Great. And just for the sake of time, Jim, I'm going to have you answer Peter's question in the chat. Just type it in, but the answer is in Anark in short. But Jim, you can add some more details for Peter there.
Yeah, so Peter, you're using Anark Workstation. You can create those steps in Anark Workstation. You can, if you have an external system that already has steps defined, we could automate the import of those different steps and other information that may be associated with a step, and then populate all that. And then within Workstation, as you guys are familiar with the BAE, you can go in and start doing more of the graphical layout and the animations that you're interested in.
Perfect.
And yes, if you do need to do it in 3D PDF for the moment, you can, or you could do it straight in the web product, either way.
Excellent. Great. Thank you, Jim. So just bringing it all back around, end to end, this is how the digital models, digital artifacts, the digital twin definition, the digital thread processes all come together so that work can be assigned and tracked, so that the feedback and traceability is closed. So you close that loop and everything starts to come together, so you don't have information flying off away from your digital thread approaches and your digital engineering approaches. It's all captured, tracked, and traced. Again, this is why, because these are the key tenets, if you will, of the 5097 instruction, which is great for the DoD audience, but is also extremely powerful for anyone with a digital engineering initiative. And that's why we wanted to bring this session together today, to really walk through some of the key highlights from the instruction that are important to consider. So that then, whether it's engineering design systems or manufacturing systems around the rest of the organization, or even, as you see in the upper right-hand corner, proprietary portals, you have an opportunity to connect all of these people to that digital twin product definition, to your digital thread processes, and really optimize the way that your business is performing. One quick example as I start to turn the corner here on wrapping this up is the recent announcement of the Organic Industrial Base, OIB, Modernization Challenge. Anark was selected as a winner. We're super excited about this project. We'll be putting a closed loop technical data exchange in place that meets the Organic Industrial Base, their manufacturing and sustainment centers, where they work. And as you can imagine, it's a diverse set of infrastructure from an IT perspective. It's a diverse set of people in different groups with different experiences, with different software, and there are silos of information all around. And so this project is setting out to do exactly what's laid out in 5097 for digital engineering, and a great opportunity for everyone to kind of follow along as this unfolds to see how it's done. So again, if anyone would like to learn more about this, we're happy to follow up and have a further discussion on this particular topic. And then other things to note, there's an upcoming Lunch and Learn. Jim Martin, who's joined us today, thanks Jim, it's a great session. He'll be going through how to get started with digital engineering content management coming up in a few weeks here. And if you'd like to learn more about that event or the Lunch and Learn sessions at large that we'll have through the rest of this year, go to anark.com/events and check that out. But in addition, if you'd like to just talk to us about your strategies around digital engineering, the instruction 5097 for digital engineering in general, how those specifications in that document can map into the types of things that you're already doing today or would like to do in the future, we are happy to discuss. We've looked at this in great detail, and we'd love for you to reach out, learn more. You can learn more on our site. We'll also follow up with all the content from today's session, or you can go to anark.com/content, send us contact us, send us a note, and we'll happily connect with you and talk about where we're going, what we're doing, and how we can help you with your digital engineering initiatives. So thanks everybody for joining today. Thanks especially to you, Jim. Great stuff as always. And we look forward to talking to you all again soon. Have a great day and happy July 4th, everyone.
Thanks, Matt.